Hi, we meet again in the next lecture. Okay, previously we have seen about pneumatic basic elements in the pneumatic system. Okay, today we will continue to our second video on pneumatic component classification. Okay, especially on the valve. Okay, valve is a part of the control elements in your pneumatic system. Okay, so we will see few types of valve today. Okay, the first type is a non-return valve, or we call it as a NRV. Okay, so non-return valve permit flow of air in one direction only. So it's only allowing in a particular direction, and the flow of air will not be allowed in the opposite direction. So we can understand that there are a few types of non-return valve available. Okay, as follows. Okay, so we have around six types of non-return valve stated here. Okay, so the first type is a check valve. The second one is a spring-loaded check valve, shuttle valve, quick exhaust valve, two pressure valve, and also shut-off valve. Okay, so this type of non-return valve are used based on the application. Okay, if your application requires the particular types of non-return valve, so you can utilize all these. Okay, so we will check one by one. So the first valve is check valve. Okay, so as you can see here, so if the inlet pressure at one is port one, is higher than the outlet pressure. So meaning the inlet pressure is more than the outlet pressure, then the check valve will allow the flow. Otherwise, in the opposite direction, it blocks the flow. So practically, if you want to understand, you only allow flow in one particular direction. Okay, so if you can see, this is the symbol. Okay, so we have the symbol for check valve. So how you can remember? So you can see there's a ball here, small ball. Okay, so if the flow is coming from this direction, so it will be blocked by this plate. Okay, while the flow is from the opposite direction, so it can go through. Okay, so that's how you can remember the check valve. Okay, the second type is check valve with spring loaded. So meaning one side will be spring loaded. So when you have a flow, so it will push this part to the spring and the flow will be allowed. And if the flow is coming from the opposite direction, so it will be blocked by the plate. Is similar like this. So when the flow is pushing this, the pressure will push the spring towards this side and the flow will be allowed to go this way. And if it's in the opposite direction, so this part will be blocked. So the flow will be permitted. So it's practically similar like a check valve, but just one end is spring loaded. Okay, so that's the second types of non-return valve. Okay, then we have a third type. So we call it as a shuttle valve. Shuttle valve is practically it's like a your OR gate. So you have two input and one output. So either one input is available, so it will be allowing a flow. Okay, similar like the symbol here. Okay, this is the symbol. So this is the symbol of a shuttle valve or OR valve. Okay, so if you have a flow here from one, so there's a ball inside, so it will block flow from another port, and the flow is permitted to the output port. And similarly, if the flow from your left hand side, so it will enter the system and it will go to the second. So if you have a flow from both sides, this ball will be at the center. Okay, so the flow will still be there. Okay, so two input and one output. So output is acquired if one of the input supply pressure. Okay, so only one input is needed. So this is the picture. Okay, so we are using the system from Festo. Okay, Festo's shuttle valve will be like this. We move. Okay, so this is the circuit diagram, pneumatic circuit diagram that you can develop using fluid sim. Okay, so you have from starting, you have your compressor and also FRL, so it's entering. Okay, so this is a non-actuated, so meaning the switch is not pressed. When you press this switch, switch 1S1, so the flow will go to your OR gate, or uh, shuttle valve, sorry, shuttle valve 1V1, 1V2. Okay, so it will allow, since only one input is required, so it will activate this DCV directional control valve and your actuator will expand. Okay, so that is how a shuttle valve will operate. Okay, then we move to the fourth type of non-return valve. We call it as a quick exhaust valve. So this is a it's like a buffer. Okay, so it's like a buffer. It's still like a shuttle valve, but it will allow a feedback. It will enter again to your system. So this is a quick exhaust valve is practically used to increase the speed of piston movement. So meaning if you want a piston to move in one particular direction, maybe it's an expansion, you want it to be a little faster than the retraction. So you can use this quick exhaust valve in order for it to expand fast but retract slowly. Okay, so this is the function of quick exhaust valve, which practically having one input, one output, and also one exhaust, which will be feedback. Okay, so you can see the symbol. So this is with silencer and without silencer. The function of silencer is to reduce the sound of the operation. Okay, normally pneumatic will have a lot of sound. Okay, the system will have a lot of sound. So because this involve air, it will be fast. So the valve will be operating very fast. Okay, so this is the operation. So quick exhaust valve during forward operation. So forward operation and also return motion. Return motion. So this part will be moved downward because the air will be entering back from port 3. Okay, so it will be moved here and you will have additional airflow in order to extend faster. Okay, so you can see the video about quick exhaust valve in internet. Okay, then we move to the fifth type of non-return valve. We call it as a two-pressure valve. So two-pressure valve is practically acting as a AND gate. So AND gate, we know if you have two input must be present in order to activate. Okay, so you have so this is the symbol. Okay, you have two ports, port 12 and also port 14. Okay, this is your output. So two input and one output. So in order to activate, to have a flow to output, so input from port 12 and also 14 must be present. Okay, so you can see here. So this is only one input from your left hand side. So it's entering, so it is blocked. Okay, similar, another side, only one input, so this is blocked. But when you have two inputs, so you can have, so the air will enter and it will go and go out because the both side is not blocked. Okay, so that is two pressure valve. Okay, so you can see in the uh, circuit, pneumatic circuit, so you have an unactuated situation and another. So okay, I will. Okay, so you have okay, so the circuit, so it's actually you have a roller valve here, 1S2, so which is by default is actuated, and you have a so if the roller valve is actuated, meaning you will have this surface. Okay, meaning it's contact to the surface, so it's considered as activated, and you have a push button here, so you press. Okay, when you press, you have two input to your two pressure valve or your AND gate. So, so the condition is met. So you have an output in your port 2 in 1v1, 1v2. Okay, so it will activate your DCV and your cylinder will be extended. Okay, so that is two pressure. Okay, then we have a flow control valve, or we call it as a choke valve. Okay, so initially we have seen the non-return valve. Okay, so we move to the second part of the video. So we will discuss about flow control valve or choke valve. So for flow control valve is actually so it influence the volumetric flow of the compressed air in both directions. So practically, if you want to put it in a simple term, so it will control the flow. It will control the flow in your pneumatic system. Okay, there's a four function. There are four functions for flow control valve. Okay, the first function is to control speed of the actuators. So you want the actuators to operate in a particular speed. So you can control the speed of your actuators. Actuators meaning your cylinders or your output of the system. So what do you want the system to move to do? Okay, so you can control the speed. Second, you can maintain the constant speed of the actuators. Okay, third function is a cushioning tool. So cushioning is practically like air damping. Okay, meaning you use compressed air in order to reduce the impact of your cylinder, because when it involves compressed air, so your device will, or the system will operate, or your valve will operate in a very fast way, because when you supply compressed air inside the system, so it will automatically or very fast it will start to move in your inside your valve. Okay, so inside your valve you have like a ball kind of structure which can block the so it can block the flow. Okay, so you need to have a cushioning tool in order to reduce the impact. And the fourth one is to control heavy load. Okay, so if you have a heavy load, okay, at the one side, so you can still do some cushioning in order to reduce the impact of the heavy load. So heavy load practically based on the gravity. Okay, so there are two types of flow control valves that we use in a pneumatic system. Okay, the first one is we call it as a throttle valve. The throttle valve, and the second one is a one-way flow control valve. Okay, so you will see each type. Okay, so we see the first type, throttle valve. Throttle valve are normally adjustable. Okay, adjustable, and the setting can be locked in one position. So you can see the figure here. So you can just twist. You twist, you can set how much flow that you want to allow. Okay, so if you open more, it will go up, so more flow will be allowed. So if you started to twist, so it will come down and the flow will be limited. Okay, so you can lock it in one position. So throttle valve are used to speed control of the cylinder. So the more you fix, so the slower will be the cylinder will be. So if you allow more flow, so cylinder will be expanding and retracting fast. Okay. So care must be taken that the throttle valve does not close fully. So if you close fully, so no flow will be available and your cylinder cannot be extended, and it can cause a damage to your system. Okay, so this is the symbol of throttle valve. Okay, we move to one-way flow control valve. Okay, this is the second type of flow control valve. Okay, so in one-way flow control valve, it's practically allow the airflow in one direction. Okay, similar like your non-return valve, but this is another setting. Okay, so you have a check valve inside. So if the flow is coming from down, so it will push this check valve and the flow uh, will be allowed. and if the flow is coming from the opposite direction, so it will push this check valve, okay, and no flow will be permitted. Okay, so in the opposite direction, the air can flow freely. So that's what I was saying. So opposite direction is from down. So it will push the check valve to allow the airflow. Okay. Okay. For one-way flow control valve, there are two setup that you can have. Okay. The first one we call it as supply air throttling. Okay. Supply air throttling meaning the supply air entering the cylinder through the working pod undergoes throttle. Throttle mean what it mean by throttle? Throttle meaning control. So you are controlling the airflow. So that's why. So supply air throttling meaning you are you are controlling the airflow at the supply port. Okay, supply. So you can see here the air is entering, and so the air is entering at this port, and when it comes here, so you know this is a check valve. So the plate will block the flow. Okay, so and no flow will be permitted. So your flow will choose this pipe. So this pipe, and and it will be slow. Okay, meaning the supply to your cylinder. Okay, for it to extend will be controlled. Okay, so this can be used for your single acting cylinder. Okay, so you can check okay how it can be done. So that is for your supply air throttling. And we have another term, we call it as a exhaust air throttling. So exhaust air throttling meaning, so they amplify this, okay, they already magnify. Okay, so you can have a system, okay, similarly, so when the air is exiting the cylinder, okay, so it will come here. So let's say this is this part. Okay, when the cylinder is entering, uh, the airflow from the cylinder is entering the one-way flow control valve. So it will go here first, and it says that it will see that the part is blocked, so it will be forced to flow through the one-way flow control valve, okay, or the non-return valve. Okay, so it will enter here, and it will be controlled. Okay, the flow here will be controlled. Okay, so practically for supply air throttling, it will it will control the airflow that enters the cylinder, and for exhaust air throttling, it will control the flow when it retract. Okay, so your cylinder will expand for supply. For supply air throttling, it will be slowly expand, and for exhaust, it will be slowly retract. So this is suitable. Exhaust air throttling is suitable for double acting cylinder. Okay, we move to the third type of valve. We call it as a pressure control valve. Okay, so pressure control valve is actually to decrease the fluid demand, okay, or sudden surge as the valve open or closes. So normally when you have a system or your valve is actuated or started, so it will have a sudden surge when the valve open or closes. So meaning because the airflow, compressed airflow appears suddenly, so it can have a sudden surge. Okay, so you need to have a pressure control valve in order to protect your system. Okay, so we call it the term as overpressure. So when overpressure meaning the sudden increase or decrease in pressure. Okay, overpressure is an increase. So you need to have a device in order to protect your system. So that is what we call as a pressure control valve. Okay, there are basically three types of pressure control valve. Okay, the first one we call it as pressure release valve or relief valve or safety valve or limiting valve. So there are various terms that is used. And the second type is pressure sequence valve, and the third one is pressure regulating valve or reducing valve. So all these pressure control valve have its own functions, okay, or application that it can be used. Okay, so we will see one by one. Okay, we will see the first type, pressure relief valve or safety valve. Okay, there are various name. Okay, so this is practically used. Okay, so it has one input and one exhaust. Okay, so it will so if you can read the description given. So this valve perform a safety relief function by opening to the atmosphere if the predetermined pressure is exceeded in the system, thus releasing the excess pressure. So meaning you can twist this part, okay, in order to set how much pressure you want the system to take. So if the input pressure is more than the pressure that you set, the remaining, it only allow the amount that you set, the balance will be released to the atmosphere. So it will have an outlet, so it will release to the atmosphere. Okay, so that's the function of pressure relief valve. Then we move to the second part, sequence valve. The pressure sequence valve. Okay, pressure sequence valve is some sort like a sensor. Okay, so it will detect whether there's a pressure change. So here also you set a, desired pressure. So let's say you set 10 bar, or okay, let's say 5 bar. So if the input air pressure is 7 bar, so meaning you have a 2 bars excess. Okay, so what this pressure sequence valve will do, it will give a signal to your control valve in order to do certain things. So whether to release or to expand. Okay, so it's considered as a combination valve. Okay, it has a 3/2 directional control valve and also pressure control valve. So it's practically acting as a sensor. Okay, and we have a third one. We call it as a pressure regulating valve. Okay, this is to maintain constant pressure even at the fluctuating supply. Okay, so let's say you have uh, is some sort of similar like the first type, but this is practically for a fluctuating supply. Okay, we have seen in the previous video pulsating flow. Okay, when you have a pulsating flow, so pressure regulating valve will maintain the constant pressure in the system. Okay, so it's more like a safety purpose. Okay, then we have a shut-off valve. Okay, so shut-off valve are non-adjustable valve. Something like we have in water tap in the house. Okay, so we have two types. One is stop valve, and second one is ball valve. Okay, so it's practically it can be only turned in whether to on the flow or off the flow. Okay, so if you twist or you pull, so it will allow flow or it will not allow flow. Okay, so there are two types of uh, shut-off valve. The first one is called a stop valve, and the second one is called ball valve. Okay, so you can use this. Okay, so the final one is called a combination valve, or we call it as a time delay valve. So time delay valve is practically like a timer. So what timer will do? It will only start the system after a certain time. Okay, so it will create a time delay. Okay, 5 to 30 seconds. Okay, once you press the push button, so it will wait until 5 to 30 seconds before it starts. Okay, so we call it as a pneumatic timers. Okay, so it's available in normally closed or normally open condition. So normally closed meaning is in the beginning, so it will be closed. Then when once the timer is activated, it will start to on the system. So normally open means always on. So once the timer is activated, it will it will off. Okay, so that's the difference. Usually pneumatic timers are on delay timers. So delay of signal is commonly experienced in application like bonding of two pieces. Okay, so it's very common to have a time delay. So okay, so time delay valve is a combination. Since it's a combination valve, it consists of three parts. Okay, the first part is a 3/2 way pneumatically operated directional control valve. Okay, NC meaning normally closed, NO meaning normally open. So you have a directional control valve. Okay, that's the first part. The second part, it has a one-way flow control valve, so meaning it only allowing flow in one direction. And the third one, we call it as a accumulator, or air reservoir or air tank. Okay, so you can see, so this is your directional control valve. So you have a one-way flow control valve, and the top part is your accumulator. Okay, so the working principle. So the air will enter here. Okay, so this is in the unactuated condition. So air will enter at port 1. Okay, and it will go to port 2. Okay, once it enter the port 2, it will come to uh, port 12. Okay, port 12 will enter. So you have your one-way flow control valve and you have your accumulator. So it will start to fill this place. Once it fills, then only it will create a pressure here to push the spring down. Once the spring is pushed, then only the flow will be allowed to the third pot. So it will take some time to accumulate. It will take some time to fill this accumulator before it has the pressure to push it down. So when the timing to accumulate in this tank, it will build a timer. In a timer to be executed. So it will cause a time delay before the port 3 is activated. Okay, so two methods to increase the delay. Okay, so this is the final slide. So two methods to increase the delay. Uh, so first, you can increase the delay by increasing the size of this accumulator. Okay, the bigger the size, the more time it will be taken to fill it. Okay, so once filled, then only the system will be activated, or you can add additional accumulators in your system. So two or three accumulators. So it will take one after one. It will fill, then only your system will be started. And the second way of increasing the delay, so you can increase by decreasing the valve opening. So you have one-way flow control valve, so you decrease the valve opening, so it will cause a delay because the flow will be reduced. Okay, so that's a short briefing about short lecture about the valve, the type of valve available. Okay, I hope if you have questions, so you can ask and you can answer the questions that will be given after this lecture. So thank you.